Good morning, everybody, and welcome to the SEMA Collision Repair and Refinish stage, powered by iCar and SERS. I am Bud Center with iCar, and this is my buddy Dirk Fuchs. And we are going to talk a little bit this morning about the expansion that we have in our Chicago Tech Center, a new tech center, around ADAS and EV. So, Dirk, what are we going to talk about here about ADAS?
Oh, that's a huge subject. So thank you. Open another rabbit hole for me to dive in. So
that's what I do.
Let's talk a little bit about ADAS and why is it so important that we as iCar starting researching and investing a lot of time in those systems. Then those systems are really critical for the consumer at the end. What we're encountering in the last couple of months, since we diving deeper and deeper in, that there are systems. They're maybe not calibrated right, but you're not even getting a fault code or a warning that those systems not operating. And that's dangerous. Now, imagine somebody comes in a really dangerous situation. That means emergency braking would react to that situation when the system would work, and it will not work, then the sensor is looking somewhere else and don't recognize there is somebody or an obstacle or whatever in front of them. So accidents could happen. The consumer, the driver has no influence on that and where we are then. So we have to dive into it, learn those systems, what we currently do, and find out and help the industry with the right informations that they are capable to repair those vehicles and have the knowledge and skills what is necessary for that.
Yeah, it's funny, you talk a little bit about some of the things that we've discovered over the last couple of months. And we have some vehicles that we've been working on, and we've done some intentional bugging of the systems so that we get the vehicle, take it for a ride, look at real-time data, and then we come back and we shim sensors so that they're off, or we make changes that you would think would pop a code. You know, you'd get a DTC or you'd get a light, or you'd go out and drive the vehicle and the system would immediately tell you that it's not functioning right. Yeah. And we're finding that that's not always the case.
Exactly.
You know, a lot of times we go out and we're driving these vehicles looking at real-time data again after we've made, we might have shim a sensor out 6 degrees or something just to see what happens. Yep. And you can see that the system is slowly learning and realizing that the sensor isn't positioned correctly. Mm-hmm. But how long does the customer have to drive it, and is there a potential safety issue, right, before the system starts to tell them, hey, there's a problem? Or you get even worse, well, maybe not worse, because another collision where the system didn't function, I guess, would be the worst thing. But if you've got a customer takes the car, goes home, they drive it for whatever it is, a couple hundred miles, and now they get the trigger and they have to bring the vehicle back, they're not going to be happy.
So you were saying we shimmed those sensors. When I would hear that and listen to you and say shim, then I would say as somebody sitting there, why you would do such a thing? And the simple answer is, those sensors, let's say a radar sensor, what is in the front, they are usually mounted on a bracket. And those brackets are pretty thin, what we're encountering. So I imagine those typical little accidents what you have in front of a shopping mall where you hit maybe a stone, there's always those big rocks what they're putting there, then they look so nice. So you hit them a little bit, and the possibility that this sensor is then a little bit out of alignment, let's say that, 2-3 degrees as you described, is pretty high. And that can happen really fast.
That happens a lot. I mean, and it's not just a bracket, right? The bracket's mounted to the quarter panel, or it's mounted to the radiator support, or wherever it's at. You get in a collision, you hit those, these parts are damaged. They need to be in the right spot when you put the bracket back on there. So we're doing that type of research so that we can help people understand why it's so critically important. Yeah. I hear a lot of times, I hear from people, well, yeah, the manufacturer says I have to do that, but why? Yeah. Why do I need to have it on a level and flat surface? In the new CTC in our Chicago Tech Center, we're going to have an area that is perfectly level and flat for doing these calibrations so that we can perform the calibration on that surface, and then on a typical collision repair shop surface, and we can start to show people this is the difference. This is why.
Yeah. So we did, for example, or we're working with a lot of manufacturers, and one of the manufacturers specifically, we had a discussion with him, and that's what we want to do as well. We want to calibrate those systems on a perfect condition to really test the functions and the functionality and build class materials also around that. But on the other hand, we want to also calibrate those systems when those environments are not perfect. So when the floor is, for example, a little slopey of maybe 1 degree, and this particular manufacturer I'm talking to there calibrate a car with a floor what was I think 1.6 degrees down, 1.6 degrees the floor, not perfect. Nobody can see that with their blind eyes that this is a little slopey. And they calibrate that, and on the end, the sensor, the radar sensor in this case, and the camera, were looking a little bit up instead of exactly in front of you, and they couldn't see the obstacle, and from 10 times, 9 times the car did not automatically stop, and it went through the pedestrian in that case, it was a dummy of course, and crashed this dummy. So the perfect environment is important, and that's what we have to create and have to have. And currently we have a tech center in Appleton, Wisconsin. We have a perfect environment there, yes, but the perfect environment is definitely too small. So when we do our calibration, it's like, oh, we have to clean up here everything what we did yesterday, and then we can make our work, and then the video team, for example, comes in and says, hey, we have to record this and we have to do this. So our space with 17,000 square feet in Appleton right now is completely limited. So and now we're going up to 47,000 square feet with our new tech center. And what the RTS team, my repairable technical support team, encountered is that when you look all those descriptions in manufacturers, what is the perfect environment for ADAS calibration, it came out you need approximately 4,000 square feet of a space. 4,000, this is a lot, and that will be a real critical subject for our technicians and shop owners out there. So our new ADAS lab, how big it is, 6.5, something?
It's going to be about 6,300 square feet. So we'll have plenty of space for that.
Yeah.
But it also gives us the ability to bring live training to the industry for ADAS. We start thinking about the course that we're working on currently, that is a 2-day live hands-on training where it's more than just learning what the systems do or how to perform calibrations. It's how to diagnose the systems when they fail. You know, when we're dealing with these vehicles that come in after a crash, you know, in a service environment, you're coming in and the vehicle just has a part failure of some sort. We have a lot of other obstacles that get thrown in the way that we need to be able to diagnose these systems. So the course focuses on teaching folks how to diagnose these systems. You know, when the calibration fails, what do you do? How do you start to diagnose this? And then we'll also obviously move into the performing static and dynamic calibrations and things like that as well.
Mm-hmm. Yeah, you know, this class will it will be our capstone class of a series of an ADAS curriculum where you go first through online training and learn really the basics of the systems, and then at the end you come to this training center and learn really how to diagnose that system when a calibration fails. So we buck those vehicles. We will have 4 vehicles, 8 participants, always a team on 2 will work on one vehicle. Yeah, and try to find a solution to the problem what we're building in. So this is great stuff. What I want to point out, and I want to move a little bit back, I personally think that in a collision repair shop, also when you're not performing your calibration in-house and say, hey, I subletting it, I have a great company here as my neighbor, and he's doing the job for me. It's fine. But I think that from a communication and understanding standpoint, in every repair shop should be one expert in this critical, with this critical content, that he can bring the car and understands what the person is doing. And that he also can say, I test drive this car after I got it back from this shop to make sure every system works. Yes, I trust my friend, it's my partner over 20 years, but is trust enough? I have to verify it. And I think with those critical systems, verification is really important. And that's the reason those folks who subletting, they have to have an educated guy as well.
And you know, that's a great point. because the liability doesn't end just because they sublet the repair out to a sublet vendor, right?
Yeah.
And how many conversations did we have when we were talking to the industry about how they currently perform calibrations and how they do these things, and got some pretty scary answers, right?
Yeah.
When we're talking to some shops that I think most would consider very advanced shops, and we're hearing that they're using a sublet vendor, but he's doing the calibrations in the parking lot.
Yeah.
There's not a system out there that I'm aware of you can calibrate in a parking lot.
Yeah.
So there's some of those things, but there's the other thing that you touched on was the knowledge that people need to have at the shop. This is more than just one person that needs to have it, really.
Yeah.
Because all the way up to the person that's answering the phone when the customer calls in needs to have an idea what these systems are, how they function, and what type of collision could potentially damage these systems so that they can make the customer aware. Is the customer really, or is the car still drivable? Is it not? You need to be able to help them with that.
Yeah.
But you need to be able to have, even an estimator, it needs to be able to have the conversation with the customer to explain the repairs that are required, talk with insurers or whoever the third-party payer might be. So it's important that the entire shop has this. Even the down to the person that's washing the cars at the end need to know how these systems should react so that when they're moving the vehicles around, they're prepared.
So I have a personal problem right now. And the problem is that on my Audi Q7 with a camera and all kinds of ADAS systems, I live in Colorado, so in Colorado every second windshield is somehow broken, and that's Colorado. So my windshield is broken. And I'm in this moment the consumer, the customer, and I think, okay, bring it to Audi and they can calibrate it and put a new windshield in. And they tell me, oh, Dirk, we don't make windshields. We can calibrate your systems, but we're not putting windshields in. But you have to put your original windshield in. I said, I totally get that. Original windshield, I have heads-up display and all those cool features. I want that they work 100%. And I know the thickness of the glass, there are differences out there. That's the reason I want to go with the OE windshield. So now I can buy the OE windshield at the dealership and they can calibrate my camera. But so who is now putting my windshield in? So now I have to find by myself a vendor who puts for me the OE windshield in, and I'm like, what the hell is going on here? Why are you guys not providing this service? So I was a little confused, but this is going on right now out there.
And it's another great point. I've been out there and actually witnessed shops that were trying to calibrate a system after an aftermarket windshield had been put in the vehicle and couldn't figure out why the calibration wouldn't accept. It wouldn't successfully calibrate. And then they realized it was an aftermarket windshield, and just the shape of the frit around the camera was enough to make a difference to not let the system calibrate. They changed to an OEM windshield and everything worked great. So it makes a difference.
I called a little bit around to see who can calibrate it, and I have connections and I know people, and I said, hey, you have a guy who puts windshields in? Yeah, call this guy. I called him and I said, so hey, I need a windshield. Yeah, I can give you an aftermarket one. Now, can you put an original in? Yeah, when you want that. So I said, so how are you dealing with calibrations? Oh, I don't calibrate a camera. I said, yeah, but you have somebody who's doing this. Oh, no. Said, so I'm okay. He marks the spot where the old windshield was located, and he puts the new windshield on the same spot. And he explains me that's the reason you don't need a calibration. Forget this.
Interesting.
So
well, hopefully you
that's
corrected
the
him on
guys
that.
right now out there who are doing this on a daily basis, and that's their business. And I was a little shocked by those answers. So, I have my friend in Denver, Robert. So Robert will put my windshield in, and then we bring it to Audi and let it professional calibrate. So the only thing is I have to make an appointment, and I always push it out. Then the funny part is my crack goes from right towards the camera, stops in front of the field of the camera, and goes down. So it's not in the visual field of the camera, and everything works.
Nice.
So
what do we have out there for all these folks that are training their staff? We've talked a little bit about the 2-day hands-on course that we've got coming up, but we didn't talk at all about the 14 courses we have currently that are online training available. Right. The training touches on everything from introducing ADAS repairs to your collision center, the type of things you need to consider, the type of pre-work and preparing the vehicle needs to be done, different types of systems, how to perform the calibrations, just with some examples. And it really is what we're using as the prerequisite courses for the
Yeah.
hands-on course, the live course. They'll have to take these online courses first to be prepared as they come into that 2-day training.
I think the team overall did a great job in putting those subjects together and make it system-based or sensor-based and explaining really in a deep content how those systems work. And when we have those calls with manufacturers or with others, always like, oh yeah, those guys who went through those courses and classes, they're all highly, they speak highly about them, so really great stuff. So I think when somebody wants to learn about ADAS stuff, ADAS systems, this is the starting point what I would do. Go on those online training classes, learn about it, understand those systems, understand maybe also the problems, what is behind there, be pointing that out, how to deal with it, and then yeah, I'm a hands-on guy. I need to learn with hands. So online is great, but you need to also go there and really, okay, how I'm doing this with the diagnostic tool. So what are those different calibration systems out there? It's for me also a big point to be really aware. You know, we referring, of course, always to the original procedures they're described from the manufacturer. That's what we're doing. That's how we're calibrating and programming those systems. So how you do this when you are an aftermarket shop and you have, for example, an aftermarket subscriptions with a manufacturer, and they are a little bit different as the dealership subscription, what we learned. You need, for example, a VSP when you want to program or calibrate systems at a lot of manufacturers. So what is the VSP?
Security professional.
Say it again, please.
It's a security professional. They need to have that security clearance to get into the systems and access those different things.
So I think this is a good step that gets organized by an organization, what is called NASDAF. They're working with the manufacturers together, and what they simply want to do is, we have now so much crucial and important data on a vehicle that the manufacturer says, I don't want to know who is the guy who's going into the deep logic of my vehicle. Then you can make a lot of things happen when you are in there. So they want to know that this guy is a professional and technician and professional what is doing this. So when you want to work on new vehicles, go to the NASDAF site and get an VSP account and register as a vehicle technician. And you need to be associated to a shop as well.
Yep. But I would say for anybody out there that's working in the collision environment and you need training on this, everybody needs training. This new Chicago Tech Center is going to be a world-class training facility. It's going to be an incredible experience for the learners, the students, and I would recommend that people start to look for it now. We hope at this point to have it done mid-May, early May.
Mid-May, yeah.
And start to deliver these courses for the industry by, at the very latest, Q2 of 2022.
Let me move back. I want to make something, point something out. My career, I was a Volkswagen instructor, always on the service side, how engine works, how electronic works, electric vehicles came out. I studied all this stuff and to learn, and always with the idea what a repair technician has to know about those systems to be capable of repairing, diagnosing them, and so on. That's my career. Your career is collision. So 10 years ago, I would not even talk to you. So,
can we go back?
So, but the point is right now that I'm sitting here and be part of iCar and part of the collision industry is simply those two industries moving closer and closer together. And the collision side has to step up their game in regards to be capable of understanding those systems. Subletting is not the answer, in my opinion, to say, oh, tomorrow I get this car in, there is like, you have an accident, the accident is not so invasive in regards to all those modern systems as back in the days. So what is possibly destroyed is the completely front, and there is like maybe 2 ADAS sensors, maybe ultrasonic sensors, there is maybe already a LiDAR sensor involved, there's a camera up there, has to be calibrated afterwards. Yeah. So can you live from only removing the bumper make a little, put some small parts in and paint the bumper, and the whole 80% of business is the electric work, and you give it away. I'm not sure if you can survive that. You know that better with your shop
it
experience.
will be tough. It will be tough to give away that large of a piece of the pie with your repairs for sure. So shops are going to need to learn how to do this stuff and start to get there.
So learn how to install those stuff, learn how to fix electrical systems, have the capability of programming and calibrating and all those stuff. When you're not going this route as early as we talk about yet, and this is not early, we are already in the middle of this game. We are maybe in the halftime right now, and then we are in autonomous driving or whatever. Right. So we are in the middle, and I personally think shops have to start mastering this game in the collision side, to keep the business in-house, to be aware of what you're doing, to set your own quality points, and quality is important, and do this and get informed and have a specialist. So.
Yep, I agree. So I'll have to apologize to the audience before I get started here, but now I'm going to move in to a subject that's going to set this Energizer Bunny off. So get ready. So now we start to talk about one of the other labs we've got in this new facility, and we start talking about electric vehicles and high voltage. So we know that there is a tremendous amount of learning that needs to happen on the collision, really probably on both sides, not even just a collision, but on the mechanical side as well, around electric vehicles. We've got 120 plus new electric vehicles coming to the market. Manufacturers have confirmed in the next couple of years.
In the next year.
And we need to have the ability to repair these vehicles, right? We need to make sure these vehicles are safe. And some of the things that we've learned through the course that we're developing, that's we've got 7 online courses that help. We focused on technician safety. We intentionally started there so that the technicians can be safe, because this isn't a situation where you can make a mistake and survive it. So you have to understand the safety side of this. So we started with those online courses, and now have moved into the live training. And some of the things that we've learned talking to folks that are out there working on these vehicles now is pretty scary. They don't understand just how dangerous these vehicles can be, and they're doing things that are not necessarily, it's shocking that they haven't, no pun intended, but that they haven't had an accident that's resulted in somebody dying as a result.
Absolute. No. Don't follow a disconnecting procedure and say, let's open those orange cable connectors and take them off. With not making sure the system is really powered down. That's the mistakes you can kill yourself. Yeah. So on one side, we didn't have really, in my knowledge, and really accident yet in the United States. Right. I know from a few factory accidents in different factories in the world where things happened, but not at a really produced car. Every system the integrity of the system is really there. So no big accident yet. What is good? But the car population currently is with 1% in the United States of electric vehicles. So 1% is not that high. So today in the morning, I was on LinkedIn, on my LinkedIn account, and I have there a German company what I follow, and we exchanging always like this is also a company what's doing training. And the guy was saying, so, hey, I get always encountered by the industry that they say electric vehicles are so complicated. And he had a video where you see all the components on an ICE engine, and then you saw the 5 components on an electric vehicle. So what is now more complicated, an ICE or an electric vehicle? And he wanted to make a little bit a positive image for electric vehicles. That was his goal. And I hear that same thing, that people think electric vehicles are so complicated. But honestly, what they see is the hybrids are out there, the Prius and all those with having range extender. The BMW i3 as an electric vehicle with range extender. This is an ICE vehicle with an electric motor or with an electric powertrain system.
Yep.
So those combinations, and when I see, I'm a BMW guy or European, I'm German, so I know those German crazy manufacturers really well. So when you see a BMW e-hybrid 3 Series and you see this 3-liter combustion engine, 6 cylinders in the front, and then you have an electric motor in the torque, where the torque converter is placed in the bell housing of the transmission, and then you have the transmission, and you have the battery, and you have orange cables, and an inverter, and a heater, and what the hell? That's complicated. That's really complicated. So hybrid vehicles, you have to know both worlds. You have to know how to power them down and work on those high voltage systems. You have to know, okay, well, how the electric motor comes in, there's a clutch, what gets locked and open up, you drive on the ice, clutch is open, clutch closed, somebody boosting, how is this all working? And there's hydraulic involved, what controls all those operations, so highly, highly complicated.
Yeah.
And then I say always, oh, my electric car, so nice overview, there's not much on components.
Right.
So, sorry, I know I went a complete different
I knew that was gonna
direction,
happen.
but I had that in my mind in the morning when we
I
were
knew that would
chatting
happen,
about
but
it.
let's bring it back to a collision repair scenario. So now we've in a typical situation with an ICE engine vehicle, the car comes into the shop, the person that's going to be writing the estimate, whether it's a traditional estimator or a blueprinter, they're going to be likely the next person in line or real close to the next person in line that's actually going to touch that vehicle. And now we start thinking about electric vehicles and the fact that that vehicle's been in a collision and the things that you need to do to ensure that vehicle's safe before an estimator even starts to touch the vehicle or do anything with that. Those are some of the things that I think are critical for the industry to start to understand.
So before an estimator touches the car, we need a technician who powers the vehicle down and makes sure the battery is in a good state, in a positive state. So what's happening, we talk to a lot of associations around the world, and we had a really interesting call with a gentleman from Scandinavia. So in Scandinavia, also Norway, Sweden, Finland, more like Norway and Sweden, the car population on electric vehicles is the highest density in the world. So they have a lot of tax assumptions and stuff, and people are going green. They want to support the environment and stuff like that. So that said, they are seeing that there are accidents, let's say a front accident. The battery pack is usually in the back. The battery pack is technically not touched or any way involved in this collision. But when you have a collision, what is the deceleration G-force happening when you hit against a wall or another car? 10, 20 G, 30 G, 40 G, I don't know, it's high. So when you see a battery is, we have the battery cells, and they are in a fluid. And you can compare that to your brain. You have your brain, and surrounded by a fluid. So now I hit something really fast, and I decelerate. It means my fluid goes up front, and possibly my brain can hit the forehead internally, and then I have internal swellings, bleedings, and other stuff. And this is what they see with the battery. So the vehicle gets repaired, nobody checks and full code, live data, or anything that, what I should check on this electric system, the accident was here in front, so they fix the accident, the vehicle goes back to the consumer, and 2 weeks later the whole house and the garage is on fire, and the car is burned down. So why is this? Chemical reactions in batteries taking time. So we have a battery balancing process. So that means every cell, a battery cell is approximately between 3.6 and 4 volts, one cell. So when we have a 400 volt battery system, what a lot of manufacturers are using, they're technically close to 100 cells in this battery. So, and then they put those, what they want or what we need is that every cell is, let's say, 4 volts, 4 volts, 4 volts, 3.9, 4.1, 3.8. That's all okay. But when it's, for example, 3.1 and the other one goes up to 5 point whatever, the difference in these cells causes a resistance. And that resistance causes temperature. And temperature is dangerous. So you would see we have then 5, 6 temperature sensors in the battery, and when I would do my job and check my live data, I look, oh, battery sensor number 2 is raised. Room temperature, let's say it's 70 degrees Fahrenheit, but that sensor is right now on 88. All sensors show 70, whatever, and this guy 88. Oh, that would be for me a red flag. Then I look into the battery balancing process and see each cell, and then I see one cell or 2 cells are deviating so strong. That's the problems what we have to make the industry aware that they look at this. And the gentleman from this association in Scandinavia asked me, Dirk, you are an expert, so how we fix this? And I said, the only way how we can fix this with our current methods, what we have, the car comes in, you check the balancing, the live data, the car goes out, you make sure you check the data, and maybe you call actually the customer and say, hey, can you come back in a week? Takes 5 minutes, want to plug my diagnostic tool in, want to make sure everything is okay. So for those electric vehicles is diagnostic tools, pre and post scanning, one of the most important things what we have to be aware, and we don't right now. The industry is not aware of that, and that's a big deal.
Yep, I would agree. So now let's talk about a different scenario. So now we've gone past the blueprinting stage, and everybody's got their estimate. We're ready to move on to repairs. Now it's time to we've disconnected something on the high voltage system, and it's time to take the vehicle into the paint booth. You know, we talk all the time in all of the other ICAR courses we have. We talk about mechanical systems, AC, whatever it is, cooling, and we talk about the importance of covering those connections to make sure that there's no contamination. So now we get into a situation with an electric vehicle, and we go into that paint booth, and we forgot to cover one of the connectors, and we just get a little bit of the overspray. Now, I'm not talking about you've painted it red. I'm talking about the little particulates that are in the air that have managed to work their way into that connector. What kind of challenge does that cause for us now?
Yeah, so I circle back. The way to bring the vehicle into the paint booth is already critical, then you will move the vehicle. So when you move a vehicle on the tires and the tires are spinning, your electric motor is spinning. When your electric motor is spinning, we're generating energy. The generated energy will be stored in a capacitor in the inverter. The inverter has a discharge time, usually 5 minutes.
Yep.
To discharge, there is a permanent passive resistor parallel to that system. Now we go deep into the electric engineering roots, but that's already critical. So best thing is don't move vehicles on their tires. Like, you have to, how you call those?
The Go-Jacks, the wheel dollies. You get the wheels up off the ground when you push them around.
Put them on wheel dollies, then you're completely safe.
Yep.
When you move them really on their wheels, cover the connectors that nobody can touch that. I would technically feel safe when I would do it, and I know there is a risk, and I'm aware of it, and I don't touch it.
Right.
So but when you're not aware of it, that you're implementing or charging a capacitor, and you would touch the cable, you would get shocked. You would possibly not die, then
it's still not going to feel good.
It feels, everybody makes mistakes. I did it once, and I got one time shocked on the training prop where but whatever.
So let's go back now and talk a little bit about that overspray and what it does.
Okay, spraying. I want to explain you something, and that goes also a little bit into electrical engineering stuff. But it's important that our technicians learn that. And resistance in a connector, high voltage connector, is we try to stay below 1 milliohm. 1 milliohm. So now I'm looking in a couple of phases. Do you guys know what that means, 1 milliohm? Who is good in electrical engineering? So regularly in our environment, back in the days, you measure a cable and want to see how this cable has a good resistance. And when it shows you, 1 ohm, 1 ohm, oh yeah, nice, I have a good resistance, all is good, the cable works. So now we're talking about cables, they are this thick, connectors are massive, high quality connectors. And we want 1,000th of ohm, not 1 ohm, 1,000th of ohm. So that would be 0.001 ohm. This is resistance what we're talking right now. And that's has to be understood by our technicians what is the resistance, and you can't measure that with a simple milliohm meter, with a simple multimeter anymore. You need a milliohm meter what works on a completely different technology. So to do this, now I give you an example. An electric vehicle, full powered up, you drive up a mountain, full throttle, takes possibly 400 amps current out of this battery pack. 400. When you take 400 amps over those cables, and we talk about 1 milliohm, and you would calculate with Ohm's law watts, the electrical power out of that calculation, you end up at 80 watts. I'm looking up to this light bulb. It's stronger than 80 watts by sure, but you know you have possibly 80, 90 watts light bulb in your house. But that goes over a thin cable or wire, to brighten it up and let it glue. Now we have those thick connectors, and this is nothing for these connectors or contactors. So now we come back to this scenario Bud described. There comes a little film of paint or
overspray,
overspraying in. You even can't see it. But going from 1 milliohm to 10 milliohm, that's like nothing. And your calculation will rise from 80 watts to 800 watts. And then we go to 20 milliohm. Oh, we are on 1600 watts. Hey, 1600 watts, guys, this is the fastest toaster what I have seen. Yep. So they're running by 8,000, 9,000 watts. And a toaster, as we know, gets really, really hot, by the way. So heating elements in vehicles, they're running by 80, 90, 100 watts in cars, for example. So it gets really, really hot. And that's only in a resistance change from 1 milliohm to 20 milliohm. So this, what you described, will raise the resistance value easily to 20, 30, 50 milliohms, 100 milliohms easily. And what the consequence is, you put as the technician everything together, think you did the greatest job in the world, the customer goes on the highway, full throttled, and he wants to race against a young guy, the power goes over these contactors, the contactors' resistance is too high, temperature increase in these contactors, the contactor starts melting, the car starts burning, and that's the situation what we hear. So one time in a month, there was a electric vehicle on the hard shoulder and was burning down, and the firefighters couldn't work and could get it out. Yep. That's the big risk, and that's another educational step for our industry, what is so important to know.
Yeah. So without taking this into a very deep technical discussion, I would just say that if for anybody that's out there repairing these vehicles, if you don't know things like insulation testing, bonding, and confirming zero potential, you need to get trained on these vehicles before you start working on these things. Somebody is going to get hurt, right?
So, absolute, and that is the least what we want. So that's the horror scenario. When somebody get hurt, is it the technician or is it the consumer? We have to have really safe vehicles. The vehicles have, from manufacturer standpoint, really a lot of safety systems embedded. So the vehicles, in my opinion, are super safe, and that's the reason that nobody died yet. Then
without the training, unfortunately, it's going to happen.
You know,
the time's
we talk
coming.
mostly about, systems come out, but when the systems it is involved in an accident, in a heavy accident, that's when the risk starts and when we are in the unknown situation.
So to close us down here, I'll just add a couple of quick things. we've done a few things as ICAR to help the industry progress as we're starting to go into this training. One is that we've developed a 5-day hands-on training course that will bring these technicians in, and it's not the type of course that somebody's going to come in and be able to sail through. You really, really need to understand this stuff by the time you come to the end. There will be a written test and a practical application exam as well that is very challenging, but it's what needs to happen to make sure that these technicians understand these systems, how to check for these things, how to test, the tools that they need to use, how to use them properly. And we've also, we had a repairability summit many months ago and worked with manufacturers and all sorts of different folks from the industry and came up with what we're calling the best practice for powering down, disconnecting a high voltage vehicle. You can find that best practice at the ICAR RTS website. There's a link right at the top of the page, can't miss it, and it will help you to be better prepared to go into the disconnecting a vehicle. But the challenge, or the piece I would say, is that if you don't have the training, this procedure is going to walk you down the path, but you may not necessarily understand what it's asking you to do if you don't have that training.
So and don't forget that procedure was verified, worked with manufacturers, workshop specialists who have the experience already working on those vehicles. So we worked with them really, really close together, but always in the mind that this procedure we developed works with the manufacturer service information. So the manufacturer service information and procedure, what they describe is the most important thing. But the problem, what we encountered and why we saw a need to develop this best practice procedure is two things. First of all, the manufacturer's informations, they're jumping a little bit with hyperlinks from different points to different points. So you can miss something. And we want to give a good guidance that we're not missing anything. So to support the manufacturer procedure.
Right.
Second of all, the procedures are mostly developed in a case of an service event.
Right.
So the manufacturer makes like, okay, we have to power down then, there's maybe a warranty work and we have to exchange a component. That's how they're developing their procedures. Now we have a heavy accident involved and there's so much more to know in this case, and we pointed out already a few of those things, that what you will not find in the repair procedure of manufacturers. So it helps, but the Bible is always the manufacturer, and we supporting the Bible with our document.
Yeah, no doubt about it. Anytime you see any kind of ICAR course, you're always going to see us saying, always follow vehicle maker recommendations, always. So, all right.
They have the experience. They're testing that system. That's our go-to point. There is no discussion about it.
All right.
Okay.
Well, Dirk, thanks for joining me up here this morning.
Of course.
Everybody, thanks for coming out. And if you have any questions,
Thank you,
we'll
guys.
be happy to answer those. Thanks.